This is the notes for 1.4, scaling to solve proportions. A proportion is a statement of equality between two ratios. Okay, so what that means is I have a fraction equals a fraction. We've actually been solving these for a couple of days when we've been comparing our concentrate to the water or the concentrate to the total. Okay, but when it's a proportion, there is no set one that has to be on top. Okay, so if I was going to compare 70 steps on a treadmill to 1.1 miles, that is a ratio. Okay, it would be okay to also write it as 0.1 miles to 70 steps. Okay, there's no specific one that has to be on top. When I get done, I've run 3 miles. So in my scenario, I would put 3 miles on top. Or in the example they gave you, they did steps to miles, so they put the miles on the bottom. Okay, so it doesn't matter which one I do, but I want those labels on there so that I'm careful when they give me that other missing component that I put miles with miles and steps with steps. And then when I go to solve that proportion, remember we could do scale factor, so 0.1 times something to make 3, or in this case, since that's not quite as obvious, I can cross multiply. I would do 3 times 70 and then 0.1 times x. At the end, in order to solve for x, we'll divide by that 0.1. So let's look at another example here. Among American doctors, the ratios of men to women is 12 to 5. So you'll notice in all of ours down here, whenever you see 12 to 5, they have men to women. Men to women, men to women, men to women. So they're adding that label. If there are about 600,000 American doctors that are men, how many are women? So when they put their 600,000 in their proportion, they were careful to always put men across from men, or I can, within the same ratio, compare men to men. Okay, so notice that label. In none of these do you see men and women either directly across from each other or below where they're not the same. Okay, every single one, it has men to men or men to men on top of each other. Okay, so no matter which way we set it up, when I cross multiply, I'll do 600 times 5, 600 times 5, 600 times 5, 600 times 5. And that's going to equal 12 times x. 12 times x, or in this case, 12 times x and 12 times x. Okay, so notice each time, if I've set it up correctly, I'm doing 600,000 times 5 and then divided by 12. Okay, because we've done men with men, women with women, so when I cross multiply, I'll always get that 600,000 times the amount of women that I know. Okay, so in our calculators, 600,000 times 5 is 3 million. And then to solve for x, I can leave that dot, or we already know that 12 and x side by side is multiply. So to solve, we would divide by 12. Our answer is 250,000 women. I know that's very large, but that is a reasonable answer, okay? Men and women, the women were about half of the men, so half of 12 would be 6. So we were looking for about half of 600,000, so half of that would be about 300. So 250 is a very reasonable answer given this scenario, okay? About half of them were women, so about half of 600,000. My answer was 250,000. I multiplied my diagonals, and then at the last step, we divided by 12. All right, so let's try another one. There are 12-ounce cookies in a 30-ounce package. We're going to write and solve a proportion to find the number of cookies in a 50-ounce package. Okay, so I'm going to go ahead and set it up 2 ways for you. There's actually 4, but I'm going to go ahead and just read it straight first. So 12 cookies to 30 ounces. Okay, that's one way. You could flip it if you'd like. Or I could set it up as 12 cookies to 30 ounces, like that, side by side. Okay, so remember, a proportion compares a ratio to a ratio. So it's up to you if you want to do cookies to ounces, or I could do cookies to ounces with ounces. But I need to make sure the one they give me is directly across from each other. Okay, Again, you could have flipped it and had 30 over here, but I'm not going to rewrite all 4 of them. Okay. So then the other statement they give me is that there's 50 ounces in my package. So in scenario, 30 ounces is going to go with 50 ounces. Over here, 30 ounces, again, goes with 50 ounces. So I can compare cookies to ounces, or cookies with cookies and ounces with ounces. Either way, when I go to cross multiply, I'm going to do 12 times 50 and then 30 times x. So 12 times 50 equals 30 times x. So in my calculator, 12 times 50, we're looking at 600. So to solve for x, we're going to divide by 30. 60 divided by 30 is 20. Okay, so if I have a 50-ounce package, I would then have 20 cookies. Okay, so keep in mind, you don't have to write down both of these. Okay, so if you want to make it all fit up there, you can just choose one, whichever proportion makes more sense to you. Okay, because notice they both cross-multiplied and got the same answer. 12 times 50, and then divide by 30. So you can either do cookies to ounces or cookies to ounces across from each other with cookies and then ounces. You only have to choose one for this when you're showing your work today. All right, our last one though, we do need to be specific. It says how many ounces does each cookie weigh? So this time I have 12 cookies to 30 ounces. And I'm trying to find how many ounces, so that would be x for ounces, does one cookie weigh. So I'm going to go ahead and do 30 times 1. That equals 12 times x. So when I solve that, I'm going to divide both by 12. So again, in my calculator, I'm going to set that one up for you. 30 times 1 divided by 12, 2.5. And that is ounces. Okay. So this is my go-to proportion. So that's why I wrote down cookies to ounces exactly like how I read it. But again, you could also write it this way. I could do 12 cookies to 30 ounces equals 1 cookie to x ounces. Or I could have flipped them. I could have done 30 ounces to 12 cookies is like x to 1 cookie. Okay? So even if I flip it, 30 ounces to 12 cookies, then I would still have my 1 cookie on the bottom to x number of ounces. I'd still do 30 times 1 divided by 12. Okay, so all you have to do for the practice today is choose one that you like the best. Cookies to ounces, or when you read a problem, cookies to ounces across from each other. Either way, I need to see your work, so I need to see the proportion set up, and then you cross multiplied. Multiplied my diagonals,